Okay, so good morning, everyone, and welcome to the second edition of DiPSCo's Reproducibility. My name is Vivian Grillo, and I'm honored to co-host this event today with my colleague Miren. So today we're here to discuss the paradigm shift towards open science, transparency, collaboration, and accessibility in science, which is also the mission of our department here at DiPSCo at the University of Trento.
As Vivian said, my name is Miren Chenevert, and I'm very happy to be here virtually with you all today. So as many as you may know, we are the first Italian journal club within the Reproducibility Network, focused on the promotion of open science. So this local initiative is within a global community, and we're dedicated to fostering open discussions on topics related to open science, questionable research practices, old and new methodologies, and representation in science.
And that's right, Miren. And we're pleased to announce that our weekly seminars are open to everyone, including students, researchers, or the general public. So the seminars will consist of two parts. A first part is a 20-minute presentation given by the students of our PhD course. And the second part is composed of 30 minutes of interactive discussion.
All right, so to kick off today's seminar, we have our colleagues Noemi Orabona and Anna Castiglione, PhD students at DiPSCo at the University of Trento. So when you girls are ready, the floor is yours.
Thank you. Hi, everyone. So I would like to start with a brief introduction to understand the meaning of this presentation. So the last decade has seen an explosion of new methodological and statistical procedures which have radically reshaped the way of doing research. This can be quite overwhelming for any researcher who wants to be adherent to this best practice, but especially for graduate students who are quickly trying to learn both the methodological and theoretical content of their specific field. So the purpose of this presentation and also the reason we choose this paper is to provide concrete suggestions for starting to engage in some open science practice that involve the entire research cycle from conceptualization to research dissemination. In particular, in our discussion, we will focus on 8 open science practices that you can embrace from today, following the format of what, why, how, and worries. We begin by briefly applying this rhetorical format to open science in general, and then move into the specific behaviors. So what is open science? Open science is a broad term that refers to a variety of principles and behaviors pertaining to transparency, credibility, reproducibility, and accessibility. In other words, the fundamental idea behind open science research practice is to be as transparent and open as possible across all phases of the research cycle in order to increase the reproducibility and credibility of one's research work. Why do open science? We can identify 2 macro reasons for doing open science. On the one hand, we can find the motivation focused on the meaning of the research. In other words, if you want to quickly increase knowledge in a particular field of study, it is necessary to disseminate reliable information and not to be gatekeepers of knowledge, so that people who want to base their research on our work can properly calibrate their inferences based on the quality of the work itself. On the other hand, in doing open science, you can gain personal benefits as well. Regarding those who wish to stay in academia, it may make sense to invest in this practice now, as they are more and more becoming part of publication or hiring decisions. Moreover, some open science practice, such as project workflow or data sharing, generally improve the organization and the efficiency of your work, which in turn correspond to skills that can be used in any type of career. What are the major concerns in doing open science? So first of all, engaging in open science practice can make one's work easier to criticize. However, if we focus on the motives related to the meaning of the research itself in doing open science, this concern should take a backseat since the main goal is to do just good science, which has a little to do with us personally. Another concern is related to the timing of publication. While it's true, it is true that some practice associated with open science, for example, larger sample size or more robust modeling may result in longer publication times. Other practice like preprints, for example, speed up the process by making publication easier. Finally, another concern is the advisor position to open science. In fact, for a senior researcher in the field, it may seem that open science advocates are arguing that everything they have learned and practiced is wrong, and therefore they may not be particularly supportive of open science. For this reason, some common concerns and how to handle them with your advisor will also be addressed in the discussion of each open science practice. So finally, let's start with the Open Science Journal Club. The first step you can take in open science corresponds to organizing a journal club with other students and staff. Usually, this takes the format of one person leading a discussion on a selected article, which serves as a conversation starter on open science and reproducibility more generally. The meetings can range in how formal they are, from a presentation with slides followed by discussion to a completely open-ended discussion with or without a moderator. It can be rated as easy because it requires minimal prior knowledge. You only need one other person to start a club, and there are already many written lists and existing structure available to follow. Why organize or attend an open science journal club? So a journal club can help you become familiar with major works and issues concerning open science. In this way, on the one hand, you can make more informed assessment and choices with respect to your position in open science. And on the other hand, you can build a network of collaborators and support in your efforts to embrace open science practice. Finally, organizing a journal club and presenting are both transferable skills for most jobs. How to set up a journal club? In order to start a journal club, you can contact colleagues in the department or outside the department to find out if they would like to participate or present something. What are the major concerns related to this practice? So you may feel that learning about open science practice is taking you away from time that would be spent on your own research. Although time-consuming, it can be a relatively small investment compared to what you can learn. You can also choose together with the group how often to hold the journal club and find together a format that may be agreeable to the majority. For example, if presenting may be costly in the long run, a free discussion can be chosen in relation to individual issues or concerns about open science. So moving on, we can find the project workflow, which refers to how you organize the projects and move through the different phases of the research cycle. For example, this includes file folder structure, document naming the conventions, version control, cloud storage, and other details. However, it involves other types of decisions as well, such as who has access to the project, for example, just collaborators or the public in general, and at what point in the process they have access to it, always or at the time of publication. Despite these choices, to keep in mind, it was rated as easy because it involves mostly organizational and record-keeping issues. Why does it make sense to engage in this practice? So having a dedicated project workflow system helps keep your research organized, enhancing reproducibility, minimizing mistakes, and facilitating collaboration with others, but also future you. For example, working in shared folders with your advisors and collaborators reduce the confusion of emailing endless version of documents. Moreover, if you decide to go public at some point, everything will be almost complete, and you will not have to create a system from scratch. Finally, having an organized workflow is beneficial in most jobs as well as in everyday life. How to embrace this practice? One option is to create a private or public project page on Open Science Framework, and then decide what to include in it. Another option for this practice is to organize a project using a variety of cloud-based storage providers, for example, Google Drive, which also offer the option of linking directly to an Open Science Framework project. What are the major concerns related to project workflow? First, you may not be clear about what you are allowed to share. In this case, it is important to consult with your supervisor and collaborators to ensure that sharing is allowed and also desired. Another concern may be related to not wanting to make your work public from the beginning. However, even just imagining that the project will eventually be public can foster taking an outside perspective that will lead to improvements in the organization. Finally, you may think that making your material public is harmful because someone else is taking advantage from your hard work, but actually you have the opportunity to gain credit in the form of citations.
Okay, so moving on to preprints. What does this practice mean? This is the publishing of a version of a manuscript that is under review, or an author formatted version of an article that has already been accepted but not yet published, or even after publication. Why should we engage in this practice? So before submission, this allows for a wider range of feedback. Publishing a version of your manuscript from which you can get feedback from the wider community can definitely help you better your manuscript before you submit it. After submission, this allows you to, of course, share your findings. And even after acceptance, this can be a helpful practice if you want to share your paper faster. We know that many times publication takes quite a bit of time, and this also allows you to share a version of your paper that is open to the community in case the journal has restrictions for access. How there are multiple platforms like Archive, bioRxiv, SSRN, and PsycArchive, which is a preprint server developed by Open Science Framework. Some worries regarding this practice. One might think that by publishing a version of your manuscript, publishing a version of your manuscript by yourself might constrain the publication process. You might think that if you do that, then a journal will not accept your paper anymore. In order to figure this out, there is this interesting platform, Sherpa Romeo, where you can check restriction guidelines from different journals, most of which will still take your paper even if you have put out your own formatted version before submission. Another worry is people will think that possibly by doing this, you will decrease your citation potential. However, this is not necessarily true. In most cases, it's been shown that actually doing this increases your citation potential because it makes your manuscript more accessible by the wider community. Scooping is another concern. You might be worried that others might be stealing your idea and running the study themselves and submitting it to a journal before you do it. Although this is possible, it is very unlikely. And moreover, all articles can be posted with a date or a timestamp, and therefore that will put a clear temporal record on your posting. Another potential problem is that your advisor might be opposed to this. So obviously this needs to be something that's shared as an intent between you and your advisor. Moving on to reproducible code. This is a medium level effort. It takes a little bit more work to engage with. What are we talking about? This is a detailed written version of your code that you use to analyze your data that would allow someone else or potentially yourself in the future to generate the same outputs in your mind that you report in your manuscript. Why should you engage in generally coding your analysis and then sharing this code? For what concerns coding by yourself, so rather than having platforms like SPSS running the code for you, this allows you to document the analysis pipeline really well, on top of allowing you to detect errors, so really keeping track of exactly what you're doing at every stage. And it enables you to make quick and easy modifications to the analysis script instead of it being a black box that you don't really know what's happening. And sharing this code, of course, facilitates others collaborating with you and really seeing what's going on inside your analysis pipeline. How can you share your code? Well, of course, if you wrote the code yourself, you can copy and paste the code onto one of the available platforms for data sharing, for code sharing, for example, Open Science Framework that we already talked about. And this would be code that you may have developed in R or Python or MATLAB. If you have run your analysis in SPSS, there is a way to copy and paste the syntax behind the analysis, even though you might not be familiar with it. SPSS does have syntax in the background, and you can download it and share it. What are some potential worries? First of all, coding by yourself is a time commitment. Of course, learning how to code is not simple, and it's a steep learning curve. However, the advantages of it is that, as I already said, it really allows you to keep track of every single step of your analysis. In addition to this, you might be worried that mistakes in your code could be caught by the community, and also you might be worried of not being a very elegant coder. However, this concern can actually be reframed as positive, especially error detection, because it allows for awareness of potential problems and correcting errors as early as possible. For what concerns elegance, it's helpful to have a coding buddy, somebody that can give a look at your code and let you know whether you commented well enough or you could change things and make them more legible. Moving on to sharing the data. With this, we mean making the de-identified data set used for a project available to other researchers. Why should you do this? In general, this allows others to reproduce the analysis that you reported in a paper and also expand on your analysis, for example, asking for more questions than the questions you asked for. It also allows somebody who might want to run a meta-analysis to really take your data and run the meta-analysis. So it would allow for inclusion of your paper in a meta-analysis project. It also might be required by a funding source or journals. It's very common that nowadays journals require that you share your data. How can you do this? There are a couple of sources that the authors mention that can be followed for properly sharing data. One is this paper from Mayer 2018 about practical tips for ethical data sharing. However, there are local and regional laws regarding regarding privacy concerns that you should definitely follow and readapt this guide to that. This is a step that should be taken during project design. In fact, this is the phase where you, for example, design a consent form that you have your participants sign, in which they will give you permission to share the data. Of course, the way you share your data should be understandable to an outsider. If you share your data in an Excel document that it's all messy and not labeled, people will not understand what that is, and it will not be helpful at all. There are, in addition, platforms or repositories where you can share your data. And again, a guideline on how to do it orderly. Potential worries about this practice are that, first of all, ethical concerns. There might be a risk of re-identification from the data that you share, especially for underrepresented populations. But there are a variety of strategies for handling this, including posting data without demographic information, for example, and other practices that Lewis 2019 talks about. Another worry could be that other researchers will conduct the analysis you had planned if you share your data, but there are also ways to mitigate this issue. For example, delaying sharing of the data set until you've answered all your planned questions. In fact, it might be that you use the data once, but you want to reanalyze the data asking different questions. So before you've done all this, you can withhold the sharing and then you can share. Or you can pre-register, which we're going to talk about in just a second, or you can restrict access to the full data set and share only the metadata, for example. Finally, you might be worried that you will not get credit for subsequent use of your data. However, you can apply a license to the data that you share. And you can, anybody who will use this data is going to be forced to cite you. Let's move on to transparent manuscript writing. Here we talk about being transparent about hypotheses and participant characteristics, for example, as well as stating and justifying decisions thoroughly. Why should you do this? So that others can really understand the research you conducted. And they also can calibrate the implications that you write in your paper from your findings. In addition, this can also speed up the peer review process. As thoroughly as you write, the less you will do a back and forth with potential peer reviewers that didn't really get what you're talking about or what you did in the background. It can also facilitate replication attempts if you thoroughly explain what you did for somebody else to repeat the process. It's also just generally a good skill to learn how to really well write or write transparently, also across the board of multiple jobs, even outside of academia. How do you write in a very transparent manner? The authors again cite some guidelines from the American Psychological Association, both for quantitative studies and qualitative studies. And they also, the authors suggest to maintain a log that as you design the project and as you develop the project and implement it, a log that documents all the decisions that you made. Some worries, it might take some time to do this. However, it may save time in the revision process if you're really clear on the front end. It might also be embarrassing to report steps such as errors that were made by the experimenter for which data was missing. However, being open about these things will definitely normalize the humanness of research and help others designing similar studies. And yeah, good reviewers will appreciate this. You might also be worried that the paper will become too long. To mitigate this, you can use supplementary materials to be more specific about certain passages. Okay, pre-registration. This is a very, very cool aspect of open science. I believe it's, again, a medium level practice. It takes a bit of effort, and it means posting a time-stamped outline of the research questions, hypotheses, methods, and analysis plan for a specific project before data collection and analysis. This is done to clearly distinguish your confirmatory decisions or hypotheses, so those hypotheses that you made before the study, and the exploratory decisions and hypotheses that you made after collecting the data and looking at it. This can be a proof of a priori hypothesis testing, and it can help you doing better inference making. How do you do it? There is, again, guides that the authors point to, and what are some worries? People are worried that this will stifle creativity and discovery by barring exploratory analysis. This is false. In fact, exploratory analyses are perfectly acceptable in pre-registered studies. You just have to clearly specify that the analyses are exploratory. Pre-registering the wrong thing might also be a concern, but you are always able to modify your analysis pipeline as far as you clearly state that you did so after data collection in your manuscript, for example. Last practice that the authors talk about, registered reports. So these are acceptance-based. In this practice, acceptance for publication is based on sound design and conceptualization. So the review process happens before data collection. So there's a first stage in which you submit a proposal of an experiment you want to run, stating introduction, methods, and analysis plan, and you get in principle acceptance. So you do a back and forth with the reviewers, and if they accept your plan, then they commit to publish as far as you stay within the guidelines you mentioned. And then after you run the study on a Stage 2, you submit the results. And if you really stick to the plan that you submitted in the first stage, then the journal has to publish this paper regardless of the results, whether they were significant or not. We have a problem in psychology, which is publication bias, where articles are disproportionately accepted for publication based on meeting a specific threshold, like the p-value needs to be lower than 0.05, or because a paper fits with prevailing wisdom. So this publication bias can be mitigated highly by registered reports, because these are accepted not based on the results, but based on a strong design, which will also allow to publish negative results or non-significant results, which can be very informative for the community, but are often fall in the black box of nobody knows what happened there. There is a practical guide on how to implement registered reports, and the author's point at it over here. What are some worries of registered reports? First of all, people worry that this might be very complicated if your advisors or committee members are not on board with this. Of course, this will vary across different countries. For some countries, for example, the USA, your thesis dissertation happens similarly to a registered report. So in that environment, it will be less likely to have advisors opposed to this practice. However, in Europe, this is something that advisors need to simply be sensitive about and also help pushing this practice. In terms of time can be a major concern for sure, and you need to be sure that this timeline can fit the kind of project you want to implement. However, you should keep in mind that while you spend more time on the front end, you save a lot of time in the last part of a submission, which is usually the one that takes the longest with a regular linear submission, where you do a lot of back and forth with the reviewers talking about results, for example. Here you do all that work on the design front. Okay, to conclude, this paper really clearly lays out open science practices, and it also points at very useful practical guidelines and resources that are accessible, especially focusing the conversation on PhD students. One limitation that we found is that the whole frame of the paper is a bit less focused on how to fill the gap between PhD students and potentially advisors that are not necessarily prone to open science practices. This is, of course, a difficult conversation to have, but I think as a community right now would be a perfect time to maybe expand on this, trying to be as open-minded as possible, both from the PhD student front and the advisor front. But it is important to discuss potential conflicts that there might be between PhD students trying to engage in open science practices and advisors that might be a little bit more conservative on this side, maybe because they've never done it before, or they don't really clearly understand what these are about. So thank you very much for your attention, and I'm going to give the floor back to Vivian and Miren.